Oysters are the living filters of the ocean, which have undergone major devastation caused by commercial overharvesting. Preservation of the oyster would require accurate oyster detection. However, systems for accurate oyster detection require large datasets, obtaining which is an expensive and labor-intensive task in underwater environments. To this end, we present a novel method to mathematically model the oysters and render images of oysters in simulation to boost the detection performance with minimal real data. We applied a sim-to-real transformation to the simulation data to obtain our synthetic data, utilizing our synthetic data along with real data for oyster detection. We obtained up to 35.1% boost in performance as compared to using only real data with our OysterNet network. Steps in the geometrical modeling of the oyster are demonstrated here. We 3D scan the real oyster, then we use splines fit to the oyster's bottom layer to model it. We extend the 2D model to the 3D model with multiple layers of the spline. PyVista is used to generate 3D models from the layers given. Finally, we apply the texture to the generated 3D model of the oysters. To generate a simulated oyster reef image, we place the oysters with random poses onto a flat surface with seabed texture as shown. However, images generated from the simulation are not photorealistic. Thus, we employed contrast unpaired translation for sim-to-real translation. As we can see in the figures, the images gradually turn into photorealistic underwater images. Here are some of the detection results. Yellow represents the oyster segmentation ground truth, and blue is a predicted segmentation result. We first display the result trained with only the real data. Then we display the result trained with the real data augmented with synthetic data. When we trained the OysterNet using real data augmented with synthetic data, false positives and false negatives dropped significantly. Here, we show how the oyster models will look different when we change the parameters that are used to model the oysters. When the parameters are either too small or too large, they no longer look like an oyster. We'd like to thank our sponsor for sponsoring this project. If you have questions, please go to the paper. Thank you.